Welcome to a brief video demonstration of the Pulse Heat Bonder, also known as a hot bar soldering system from Fancort Industries. This equipment is primarily designed to bond flex circuits to printed wiring boards and ceramic substrates using hot bar soldering technology. It can also be used to bond surface mount edge connectors and ribbon cables to circuit boards. This equipment can also be configured as a heat seal system to create connections between components such as heat seal connectors to circuit boards, LCDs, or tab devices. The difference between our pulsed heat bonder and our heat seal bonder is that a pulsed heat application requires a heat profile to ramp up, control, bond, and cool while the bond is under pressure. This ensures that the bond makes the proper connection to all areas without voids, bridging, or contacts moved out of position. A heat seal system will utilize a steady temperature with no ramp up or cool down, but still under constant pressure. The primary elements of the Fancort pulse bonder are a floating titanium thermode, a holding fixture, a sliding linear shuttle or rotary table with 2 work positions for increased throughput, and the controls to operate the machine. The bonder incorporates a microprocessor control system that will allow the operator to accurately program and control all elements of the bonding profile. These parameters include pressure, temperature, ramp-up time and speed, bonding time, and cool-down time. The controls mounted on the front panel allow you to program and edit a heating profile for a specific application. The software can store up to 4 programs at one time. The pressure switch panel is used to adjust the air pressure to regulate the amount of bonding force that the thermode will place on the bonding surface. The titanium thermode is designed according to the dimensions of the bond area for the specific application. For example, a 1-inch long flex bonding area would utilize a 1-inch long thermode. Typical edge width of the thermode, which is part of the thermode contacting and bonding the flex, is 50 to 80 thousandths inches thick or wide. Thermode is also designed with a slight float when attached to the unit. The purpose of this float is to compensate for any small variation in the Z-height across the flex area being bonded. The fixture mounted on the linear slide or rotary table is designed to hold the elements in place that are being bonded. The fixture holds and locates the flex and substrate so that the bond is processed properly and in the correct location. The fixture will repeat the bonding process time and time again as long as the proper parameters are programmed in the heat profile and bonding force programs. In the case of our calculator example, you can see the fixture utilizes pins to locate the substrate and flex material. Heat-resistant ESD-safe thermoplastic material is used to support the substrate at the point of the bond and also outlines the LCD in this situation for alignment. A vacuum hookup built into the fixture creates a hold down for the LCD and the flex before, during, and after bonding. All these features ensure that the alignment of the flex over the pads is accurate for each and every cycle. Other features used in the fixturing of the flex bonding include machined cavities and edge supports for double-sided substrates and mechanical hold downs. An optional CCD color camera system is available to assist the operator in loading and bonding, especially if an adjustable fixture is required so the operator can visually bring into alignment the 2 elements to be bonded. This concludes the overview of the pulse heat bonders and heat seal bonders. The next section of the tape involves the actual programming of a profile and a demonstration of the bonding process. Let's examine how easy it is to set a profile for our calculator assembly. You may wish to have the operating manual handy during this section of the video. First, we press the return key to enter the next menu to select our editing mode. Once in the next menu, we move the cursor to select Edit Program and press Return to enter the next menu. Once in this menu, we enter the password, holding the return and down arrow at the same time. This is quite sensitive as both must be pressed at the same time and it may take several tries. Once this is accomplished, you will be in the next menu so you can choose the program you want to edit. In our example, it is program number 1. Once you have chosen a program from 1 to 4, you can set the parameters in the heat profile. The up and down keys move the cursor to the parameter you wish to set. After choosing the particular parameter, you press the return key, which will move the cursor to the numeric value of the parameter. The setting can then be adjusted with the up and down keys. Once you have set the value to what you require, press the return key to move to the next parameter that needs to be set. The parameters of the heat profile include idle temperature, first ramp speed in 1 second increments, preheat temperature, second ramp speed also in 1 second increments, reflow temperature, reflow time, and cool down temperature. Once all your parameters have been set, select Save and Exit, press Return, and you will be back to the Edit program. Once in this new menu, you will select Quit to exit and return to the first menu. The other setting that is required for the bonding program is the adjustment of the Thermode bonding force. Bonding force is programmed by setting the first two settings, P1 and P2, on the pressure switch panel. These values represent the lower and upper limit of bonding force. These values of air pressure translate into Thermode output force measured in newtons. A table is provided in our operating manual showing the amount of Thermode output force for the air pressure values of P1 and P2 settings. When setting the upper and lower limit values for Thermode force, they should be set at the bonding force range that will maintain the ideal bonding pressure within an acceptable range. In our programmed example, the ideal bonding pressure measured in newtons is 280, but we know from experience that bonding can be done from 270 newtons to 290 newtons. Consequently, P1 is set at an air pressure value of 280. The P2 value, which is the upper limit, is set at 0.310 air pressure value. These settings will provide our desired bonding force of 280 newtons plus or minus 10 newtons. The machine we're seeing in this video has a linear shuttle. The operator loads the work onto the fixture and slides the shuttle into position and presses the start button. A higher production machine is available with a rotary table with 2 fixture positions. The operator loads the work onto one position while the other position is doing the bonding. 2 models of this machine are also available, one with a pneumatic table and one with a manually rotating table. Now let's see the machine bond these 2 calculator parts. For demonstration purposes only, the bonding cycle in this example is approximately 25 seconds. A typical production cycle for the machine is anywhere from 8 to 15 seconds. That concludes this brief video of the Fancort Pulse Bonder. For additional technical information or to discuss your application, contact Steve Hoover at 1-888-FANCORT or by email at shoover@fancort.com. Or visit our website to learn about all our Fancort PCB production equipment, including robotic soldering systems, circuit board depaneling machines, racks and fixtures for PC board assembly and handling, and SMD lead forming equipment and services.